Welcome back, everyone. Dr. Lindner. We are now going to be talking about the RAS system. And the RAS system is the renin, angiotensin, aldosterone system, right? Renin, angiotensin, aldosterone system. So let's take a look and have an understanding of what's happening in this diagram. It looks complex, but I promise I'll be able to make sense for you here. So we have something going on in the body where the blood pressure is dipping, okay? Maybe their blood pressure is dipping because they are dehydrated. Maybe there is a sodium deficiency, or maybe they're losing blood. Whatever is happening here, there's a decrease in the volume of blood, which is decreasing the blood pressure. And the kidneys here don't like low blood pressure because all the blood is flowing through this motor of the kidney, and the kidneys need fluid going through it all the time. Otherwise, the motor burns out. So there are JG cells, juxtaglomerular cells, JG cells, that are kind of sensing what the blood pressure is like, okay? And if it senses that it's dipping, the kidneys are going to release a hormone called renin. And again, the first three letters of renin are ren, like renal. What is the function of this renin? The renin has a very, very important function. If you look to the left, we have our good friend, the liver. Now, the liver is releasing this hormone called angiotensin ogin. Now remember, anything that ends in ogin is inactive, like glycogen, it's inactive. Pepsinogen, it's inactive. So angiotensinogen, if we look at the name, angio is blood vessel, tensin has something to do with tension. So we have this hormone that is inactive because it's got ogin, but it's going to be involved in regulating blood pressure somehow. But how do we activate it? Well, renin by the kidneys are going to bump into angiotensinogen produced by the liver. What renin does is when it bumps into it, it's going to knock off the ogin and produce angiotensin 1. Again, renin is going to activate angiotensinogen into angiotensin 1. Now, it's safe to assume if there's an angiotensin 1, there's going to be an angiotensin 2. But what is it that converts angiotensin 1 into angiotensin 2? Again, what is it that converts angiotensin 1 into angiotensin 2? Well, this is going to be something that the lungs produce called ACE, or angiotensin converting enzyme. Angiotensin converting enzyme, ACE. Now, isn't this amazing? We're talking about blood pressure here. So we have the kidneys that are involved in regulating blood pressure. We have the liver that's involved and the lungs. Who would have thought, right? Most people think if there's a blood pressure problem, it's just the heart. But the heart is just the last organ that is expressing the symptom. The imbalance can be at the kidneys, it could be at the liver, it could be at the lungs. Okay, so now we had low blood pressure, right? We had maybe dehydration, decreased sodium, hemorrhaging, we had a decrease in blood volume, decrease in blood pressure. The juxtaglomerular cells of the kidney detected that there was low pressure, so it released renin that bumped into angiotensinogen that was produced by the liver. The renin activated the ogin, and now we got angiotensin 1. The lungs produced ACE, angiotensin converting enzyme, which, by the way, is zinc dependent. Zinc dependent. Zinc is not just important for the immune system, it's really important for lung function as well. So now ACE was involved in converting angiotensin 1 into angiotensin 2. Now, once we have angiotensin 2, what does angiotensin 2 do? Its basic job is that it's going to increase blood pressure by a few ways. Well, how is angiotensin 2 going to increase blood pressure? Well, it's going to constrict the arteries. And when you constrict the arteries, you increase blood pressure. Angiotensin 2 is going to stimulate the adrenal cortex. And the adrenal cortex can produce cortisol. It can produce, the adrenal cortex can produce aldosterone, a mineral corticoid. When you deal with aldosterone, which is a mineral corticoid, is involved in conserving sodium. When you increase sodium and water absorption, you get an increase in blood volume, you get an increase in blood pressure. Okay, that's called the RAS system. When we come back, we'll talk about the adrenal glands a little bit more, but in relationship to stress and how stress can kill.